So today we are going to see about the hybrid search with the Qdrant vector database. So Qdrant database is open source database which provide the hybrid search. So what exactly is hybrid search? Hybrid search is the combination of semantic search plus the keyword search. Let's see what exactly is the semantic search and what exactly is keyword search. Why do we need hybrid search? First thing is like, what is the semantic search? Semantic search is like where we understand the meaning of the text. We create some kind of semantic relation between them. Then the keyword search is like, instead of understanding the meaning, we try to find the exact words that is present in the query. The hybrid search is the combination of both of them, where we try to find the data which has the semantic meaning as well as which contains the keyword. So Qdrant help us to do that in an efficient manner. So I'll give you the example. Let's say you go to e-commerce site and you search for best laptop with the best memory or best performance, right? And you get the result of various laptops. Even though on those laptops description, you not might not find that it has the written laptop itself. It might return that it is a MacBook Pro, right? Even though the word is not present, we are getting that result. That is because of the semantic system which the e-commerce have implemented on their search system, and we are getting that data. So with hybrid search, we are getting best of both the worlds. We will get the keyword search result also and the semantic search result also. So for the hybrid search, like Qdrant will give us even the reranker. Like reranker here is ColBERT, and we can provide the dense embedding here. Dense embedding is the semantic embedding which I was telling, and the sparse embedding is the keyword search. So for dense embedding, we can use any embedding models which are currently available. So Hugging Face has like free embedding systems which we have, like OpenAI provides that, Gemini provides the embedding systems, and the sparse embedding is the keyword search. So there are many algorithms to do the keyword searching. So one of the best probably is the BM25, which we will be using here. And there's another thing which is late interaction embedding. So this is where we have the re-ranking thing that happens. So let's say we have a document, we have to create these embeddings and we'll store in vector database and we'll get the results. So let's see how exactly that happens. At the time of ingestion, whatever document we have, will for that document, we'll create the dense embedding, we'll create the sparse embedding, and we'll create the late interaction embeddings. So here, like, we'll be using the covert, or we will be storing all of them in the vector database. So like the hybrid search is the combination of dense embedding as well as the sparse embedding, that is the hybrid search, and whatever result we get from both the embeddings will re-rank with the help of the re-ranker, and that is where the ColBERT will come into the picture. So retrieval stage will be like user will do the query and will create the embeddings, and then we'll do the hybrid search. Hybrid search is the part where we'll do the searching on the basis of dense embedding and sparse embedding, and then we'll do the re-ranking. So once we understood what exactly we're trying to do, I'll walk you through the code, like a real example where we'll be ingesting the data in our Qdrant database, and how exactly the results will look like. I'll show you that. And then we'll look into the database, how exactly we'll visualize how exactly those embeddings looks like. That will give us the better understanding of this whole system. So let's jump on the code, like see how exactly we'll implement this hybrid search. So let's start with the requirement. Like we will be using fast embed. Fast embed will be used to provide us the better way to create embeddings. Then we will be using Qdrant client, that is to connect to the Qdrant. Like this is for the Python for the environment variables. So you can go to the Qdrant and get your API keys from there. So mostly you'll be using you'll be needing the Qdrant URL and the Qdrant API key, that you can easily get it from the Qdrant. Like it's free, and its free tier is really great. Like I have been using it for my side project and really satisfied with the kind of usage they provide in the free tier. Like one of the best which we can get for the vector database, and you can use it for the free. So the next thing is like this is the code which we have, right? So I'll start with the example which like document which we will be using for embedding and like the queries which we'll be getting. So here the example is sample queries. The data which we will be using is on the basis of the machine learning topics, where we will show like how exactly semantic and keyword similarities are different. So the capabilities of that. A few documents, each document in this array is considered as one document, and we will keep this data in our database and we'll search these queries. These will be the example queries. So like the example query could be how to prevent model from memorizing training data. So like this is, if you know about machine learning, you understand like this is relating to the overfitting. Overfitting means if your training data, you just give the training data to a model and model understand that better and provide the patterns on the basis of that. So these are the few example queries which we will be running over that, and we'll be seeing like how exactly the results will come out on the basis of these documents. These will be the documents which will be stored in our database, and these will be the example queries which will be running. So our code will look like something like this. Like we will have the first, like this is for initializing the client. Mostly like we'll get the Qdrant URL and Qdrant API key from the Qdrant Cloud. Like you can, I guess you can do with the Docker also, but I already had this setup there and I really like it. So I'm using that particular URL and API key right away here. But I guess like they have the Docker image also, and you can spin up your Quadrant in local. It's an open source thing. Then we'll initialize the model. So I told you like we'll be needing the text embedding, sparse text embedding, and the late interaction text embeddings. So all the models which we'll be needing will initialize here. So here we'll be using the sentence transformer for the text embedding. You can use OpenAI one or Gemini if you want. And we have the for sparse like Quadrant provide BM25 model. I think we can have our own algorithm also, but I think if they are providing, it's better to use that. That will be give you the clean code and better efficient way to generate the BM25 in embeddings. And there's a then we have the Cobalt 2 point Cobalt V 2.0. So that is also for the late embedding that we will be using for the re-ranking. So first thing we will be doing is creating a collection. Our collection name is demo hybrid search. So that collection we will be creating. So in that collection, we will provide like the schema which we wanted to create. So in this schema, we'll provide the vector configuration, like what kind of vectors we will be wanting. So there are two types of vectors which you can see. Like one is for the dense vector for we will be having the this all mini lm L6v2, and another like all the configurations we needed for the vectors we will be keeping it here. For sparse vector configuration we will be using BM25 provided by the Qdrant. Then we will index the document. Index the document is like the documents which we have in our example files, that those documents will take it, and for each document we will be creating the dense embedding, sparse embedding, and the late interaction embedding. And then the queries which we have, right? I have already shown you the three queries which we have. So those queries will run on those particular collection, and we'll get the data. So let's see if we run it, right? So what happens, like if we'll run it, it will load those embedding models because I have already loaded before. So I need not to load it. Otherwise, it will take little time for you to load for the first time. So see, like this is the first query which we have, right? How to prevent model from memorizing training data. So it is telling you about the overfitting. even though we haven't explicitly mentioned any word in the question about the overfitting, but the model understand, like we are talking about the overfitting. So this is like the semantic relation that provides that particular power to the models to understand that. And the other thing, like if we wanted to have the gradient descent optimization, so it will provide you the all the documents where we will be having the gradient descent. Actually, these words present, so those scores will increase there. So similarly, like if we have pre-processing data for neural networks, so for all the steps that we required for the pre-processing for the neural network is similar to what we have for the machine learning. So the first record which we got is data pre-processing step essential before training machine learning model. So it is talking about those things. So our searching is basically the combination of both semantic search as well as keyword search, and we are re-ranking on the basis of we have the re-ranker to re-rank those. Now, once we have actually ingested data, and let's see how exactly our data will look in the database. So we have created one collection that is demo hybrid search. So our collection schema, if we look into, will have that schema, and the schema have the vector which we have created while the collection creation. So this particular vector has the size of 384, and we are trying to do the similarity on the basis of cosine. And similarly for the covert, it will be have 128 size. So how exactly covert work is like for each token which we have, we create we create a vector for that particular token. So I'll give you the example. Let's say we have a sentence in which we have around 100 tokens. That means for each token, we will be having 128 size vector. And that comes out to be the total size of that particular token will be around 128 into 100. That is around I think 12,800. So something like of those size will be there. So covert is like the size of the data which we have for the ranking that increase a lot for the database. So that increase the burden. Similarly, we can see like we have the sparse vector configuration here, which we have created. So we can see this here. So let's see like how exactly our data will look like with vector. I have specified with vector. So we can see that this particular UI is the cloud UI, and I'm using that. And one of the reason with for which I'm using the Qdrant Cloud is this UI also. This make it really simple to understand and see the data. So let's say I really loving it, even though it's not at all sponsored, but I'm really loving this. So yeah. So let's see how exactly our data will look like. So for data, we have this particular API. So collection, we have to provide our collection name and then points and then scroll. We have to provide the limit like how much data we wanted to have. Let's run this. So we provided with vector. So we'll get all the vectors also. So this is the first data which we have. So if we look into these, this is the vector which we have, right? So there are three types of vectors which we have. One is covert, another is for the dense vector. This is for the sparse vector. So if we look into sparse vector, this will tell us the index of that particular token. Like sparse is like basically we provide the index and the value of that token. So sparse we are keeping on the basis of index as well and the value, both we are keeping it here. And then we have the covert. In covert, I was telling you like in each token we will generate 128 size vector. So if we look into like see this is in covert we have around 128 size of this particular vector for the token, and all the if you look into here like it's around 4,000 keywords. So for that particular sentence we will be having this particular covert vector. And then we will be having a dense vector that is 384 size. You can see that particular vector here. So this visualization will help you to understand like how exactly your vectors are stored and how much storage it will be using and how can you optimize it. I hope this video was helpful for you and you'll create awesome application with the help of hybrid search on Qdrant. And do let me know in the comment if you have some idea or you are trying to implement something. Keep learning, keep building. Goodbye.